Circuits! Battery, big line, small fat line, long big line, short fat controller. Yeah. The electrons come out in that direction, makes an arrow. 2 batteries. Well, 2 cells making a battery of cells. Officially, but people call them batteries. Light bulb. Yeah, that's with a cross. That's an indicator light bulb rather than one that's used to light a whole room. Where one that's used to light a whole room is like that. Wires, just straight line. Ammeter, A. Voltmeter, V. Okay, right, we've obviously got a battery of 2 cells, 2 light bulbs and a voltmeter. The voltmeter's in the right position, the voltmeter's not in the circuit because voltmeters have lots and lots of resistance. So you can't get many electrons through, but those that do go through tell me how many volts there are. Good circuit, voltmeter parallel, like 2 parallel lines. That's where the bulb should be on that parallel line, and that's where the voltmeter should be on that parallel line. And of course, you know, the cell has to be somewhere else. Yeah, circuit. Voltmeter parallel to the lamps. Battery of 2 cells gives 3 volts. Yes, because each cell is worth 1.5 volts. Have a look on the cells you've got in your remote controls and they'll say 1.5 volts. The batteries inside your mobile phone give more than 1.5 volts, and the battery in my camera gives more than 1.5 volts. But the batteries that you grab hold of and put into remote control, 1.5 volts each. Okay, right, broken circuit. Oh yeah. 2 cells can keep 2 light bulbs going. Broken circuit. Oh, where's the break in the circuit? Oh, there it is. Broken circuit. Fix the circuit in red. Oops, I done it in blue. Never mind. Broken circuits are called incomplete circuits. Absolutely. 1 cell giving 1.5 volts. 1 lamp needing 1.5 volts to light up to white hot. 1.5 volts, it says. Good parallel circuit. Parallel circuit. See, okay. AAA cells give 1.5 volts. AA cells give 1.5 volts. Yeah, the voltage is due to what chemicals they put inside them. They put the same chemicals in. Incomplete circuit. Complete the circuit in red. I'm going to do it in blue. 1 cell gives 1.5 volts. Okay, where's the... oh, there it is. Yeah, with 1.5 volts, the electrons can't jump across the air gap, so it has to be filled up with copper wires. So copper wires all the way around. This is a good circuit now. Now, this will go 1.5 volts. Now I've completed the circuit. Next one down. Good parallel. Good parallel. Okay, rather than parallel lines this way, we've now got parallel lines this way, but they're still parallel. Good parallel. 1 cell gives 1.5 volts. Each bulb wants 1.5 volts. Circle in red. Oh, I'm going to use blue. The component not in the circuit. 1 cell gives 1.5 volts. What component is not? Oh, that one. Circle the components. Oh, and that one is not properly in the circuit, so they won't work. That's not good. Right, okay, here we go. Voltmeters in parallel. 2 cells is 3 volts. Shared by 2 bulbs. Yeah, okay, both light bulb has 1.5 volts. There's 2 voltmeters involved here, so everything's good. Let's have a look over the other side, on the not so good side. Good parallel. 3 volts shared by 2 bulbs. More than 1.5 volts will melt the bulb's filament. Yeah, the very thin wire. Filament means very thin wire. The very thin wire inside the light bulbs would melt if you have 3 volts. Oh, everything's good about this one. This is a good one. Okay, this one's not good. This one is good now. And this one is good. Okay, here we go. Next one down. Okay. 1, 2, 3 cells, 1, 2, 3 bulbs. That's using 3 volts. That's using 1.5 volts. 3 cells give off 4.5 volts. Everything's good. Good parallel. 3 cells give 4.5 volts. Less than 1.5 volts will make a bulb dim. Yeah, if you've only got like a one bulb, it will just light up red. Not very much light. Voltmeter in series. Oh, that's no good. That shouldn't be there. It should be in parallel, like that. Yucky, yucky. Bulb doesn't work. No, if you put the voltmeter there, like I said, so much resistance, electricity can't get through. Not enough electricity to light the light bulb, that is. Voltmeters has lots of resistance, so fewer electrons get through. Cool. Voltmeter, not in parallel. Oh yeah, that one's not in parallel. That's in series again. Hold on. That's where it ought to be. Voltmeters have lots of resistance. Bulb, not a light. No, it wouldn't be a light the way it was first. Right, okay, hold on. Let's do this one down here. Good. Parallel. Fill in the voltmeter readings. Okay, I've got 4.5 volts coming out of the bulbs, because I've got 3 times 1.5. 3 times 1.5 equals 4.5. Okay, this one's going to be 1.5 volts. This one's going to read 3 volts. Everything's good. Tick. What's it say over here? Draw a circuit with 2 bulbs in series. 2 bulbs in series. Okay, 1, 2. 2 bulbs in series. In series. And a voltmeter that will read 3 volts. Okay. 3 volts. Okay, well, what's giving the electricity? Also, I do need to have 2 cells. Doesn't matter which way around they're pointing, just as long as the electrons can go round. Paching! Tick! Draw a circuit with a voltmeter that will read 4.5 volts. Oh, okay. So, 4.5 volts. I need 3 bulbs. They can be like that. And a voltmeter. 4.5 volts. Okay, so they're all in a line and the voltmeter's reading all of them. Now what is giving me the 4.5 volts? 1 cell, that's good. 2 cells, that's good. I can put the 3rd cell down here if I want to. 3 cells. Yeah, okay, it's a bit more complicated than it had to be, but it's full marks. Good. Press like, press subscribe. My name's Good Luck Gary. If your parents want me to help with your maths or your science, then you should tell them to get in contact with me via goodluckgary.com. And I can't find my... Press subscribe. Get my other... oh, there it is. Phew. Good Luck Gary. HK@gmail.com. Bye!